All right. Two other operations we can do on them. Multiplication and division. So if we have two functions, f of x and g of x, we can find their product by multiplying the two. F of x, and then the dot for multiplication, g of x. Or it looks like this. F times g of x. For division, we would take f of x divide g of x, or it would look like f over g of x. With division, one important thing to add, g of x, like I can do the division as long as g of x is not 0, because we can never divide by 0. Okay? All right, so doing similar examples. Here we're given one function x plus 2 minus 5, and then g of x is 3x minus 4. We are asked to find the equation of the function f times g of x. So we would take x plus 2 minus 5, all in parentheses, times 3x minus 4. And then we would simplify that as much as we can. Well, I can simplify this, can't I? This is the same as x minus 3. And I can multiply these two binomials, you guys have been doing that for 3 years, to get 3x squared minus 4x minus 9x plus 12, which simplifies further to 3x squared minus 13x plus 12. So that's as simple as you could go. Finding the domains of their product is the same thing as addition and subtraction. Find what's in common. Well, both of these, x minus 3 and 3x minus 4, are lines. So the domain of f of x is negative infinity to positive infinity. The range, keep going to say range. The domain of g of x is negative infinity to positive infinity. So combined, the domain of f times g of x is negative infinity to positive infinity. Right? Let's look at a division. Okay, here we're given two functions. Notice, slightly different. We're asked to find the equation of the function g divide f of x. So that will give us x minus 2 over x squared plus x minus 6. The question is, can that be simplified?
Yes.
How?
We need to do brackets in the bottom.
We need to factor the bottom, because then you're going to find, when you do the bottom, you get x plus 3 times x minus 2. But before you cancel, what are the NPVs, non-permissible values? What can x be?
Negative.
Yeah,
Negative 2.
not negative 2.
Oh, 2 and negative 3.
Negative 3 and 2. And then we can cancel these down to 1. and be left with 1 over x plus 3. What's the domain of this new function? Well, before we canceled, this was the function, right? Okay. But we said x can't be 3 and x can't be 2. But if we took the domain of each of these, this is negative infinity to positive infinity because it's a parabola. This is negative infinity to positive infinity because it's a line. But when we combined them, we saw that x can't be 3 or 2. So we have to exclude negative 3 and 2 from our domain. The domain of this would be, this is how you would write it. What this means is everything except for those two. Okay, we can't do negative infinity to positive infinity even though we want to. Because we saw there were a couple of values when we divided that would make it undefined. Okay, now this last one. Again, we're going to do a graph. We'll just do multiplication. Remember, we can only graph the domains that they have in common. So our x values are going to be -6, -3, 0, and 3. And again, find the y values for each of them, but this time multiply them together. So I get 4 times -1 equals -4. For -3, I get 4 again, but this time times -2 gives me -8. For 0, I get 1 times -2, which is -2. And for 3, I get 1 times -3, which is -3. Plot those new points and connect. So -6, -4 is down here. -3, 8 is up here. 0, -2 is down here. And 3, -3 is here.
It's not negative again.
Did I get it wrong?
Yeah.
Where did I get it wrong?
-8.
Oh, -8, shoot. Thank you. -3 or -8. And that's the effects. So very similar to addition and subtraction, except you got to watch out in division. You got to watch out for restrictions or non-permissible values.